Hey guys, this is William Burnett. I'm one of your graduate TAs for General Chemistry Lab. Today I wanted to go through the technique associated with experiment 1, which is the difference between accuracy and precision, and also the determination of the formula of a hydrated salt. So before we get started, I wanted to cover a few other things. So you've seen, hopefully, Dr. Conrad's video, which actually goes into the intricate details regarding the experiment, such as reading the meniscus, significant figures associated with the different pieces of glassware, using the balances, keeping them clean and everything like that. So this video will specifically cover, will be more of a walkthrough of the actual experiment and the techniques that will be used. So next we have our safety elements that we need to consider. So number 1 is going to be eye protection. So either you have safety goggles that you've purchased from Chem Club. Those are probably your best option. Next is going to be a lab coat, probably from Chem Club as well. And then the other will be gloves. Gloves will be provided for you in the lab. And so let's put those on. So a couple other things you'll need is your lab notebook with everything written out already, your data tables and procedure included. And then let's go ahead and jump into it. So part 1 is going to be determining the accuracy of a graduated pipette. So here we have our graduated pipette. This one goes 0 through 9, and then the last milliliter is actually contained within the tip. So this is going to be a blowout type pipette, one that you can completely clear of all the liquid. Others you have to pay more close attention to. They will say 0 through 10, and that last milliliter must be stopped at the 10, otherwise this bottom is not accounted for. Next we have our pipette pump, which the pipette slides into. So it simply slides into the bottom down there, and then you have a wheel where you can actually use to suck up the liquid, and you can either use your thumb to remove the liquid or open this little stopcock here, which actually allows air into the top and liquid to come out the bottom. One important thing about these is that you can ruin these if you get liquid actually inside of them, so do not turn these upside down if there's any liquid in the pipette. So do not have liquid in it and then turn it upside down. Alright, so first thing we need is a clean and dry 50 milliliter beaker. We're going to take this and place it on our balance that has already been zeroed out. Close the windscreen and allow the balance to settle. Once the balance is settled, you will record the mass of your beaker. You can remove the beaker. Over here we have 2 larger beakers with water already in them. We have a thermometer so that we can record the temperature of the water because the density of the water is very important to determining how accurate our pipette actually is. Next we will take our pipette and pipette pump, actually attach them. We will take our water, bring up our first 10 milliliters. Be careful to pay attention to the tip. If there's any air that shows up, just be very careful about that because that will change your measurement. All right, we add our water back to the beaker. All right, and then now we're going to take the mass of our beaker again. So opening the windscreen, placing the beaker on the balance, allowing the balance to settle. And then we're going to record this mass again. Remove the beaker. Now we're going to add 8 milliliters of water. So now we have our 8. I'm going to add that. And then we're going to take the mass of the beaker again. Allow that to settle. Your balance will not be this conveniently located. They're actually located in several locations around the room. With the half capacity that we have this year, we shouldn't have very many issues with lines building up as we have in previous, so that'll be nice and convenient. So I've recorded my mass again. And then for the final, we're going to add 5 milliliters. 5. And record the mass one more time. All right, so now that we have recorded all of our data for part number 1, we can move on to part number 2, which is going to be determining the accuracy of a burette. So here we have a burette with a stopcock down here, and this goes up from 0 to 50 milliliters. We have a ring stand with a burette clamp attached to it as well. This is very helpful for actually using the burette. So open your burette clamp, place your burette inside of it, and then we can fill it. You have a couple of options with filling. You can either use with filling our burette, you can use a funnel if you would like. You can place it in the top. If you want, you can add a small piece of paper in there to allow a gap for air to pass through. I personally like to fill the burette with a beaker because it has the little mouth on it, which pours pretty easily in there. So you want to check that your burette is closed. And then slowly add water to the burette. So down at the bottom of your burette, there is a tip. This tip needs to be filled with whatever liquid you're dispensing before you actually attempt to measure. So I'm going to place the same beaker that had my water in it. I'm going to open that and allow the tip of the burette to fill before I actually use the burette. Now I'm going to fill it past 0. And you don't have to start at 0. Now I'm going to fill it past 0. You do not have to start at 0, as long as you write down what your starting volume is to the appropriate number of significant figures. So slowly dispense the liquid until you hit the appropriate start point where you like. I like to start at 0. Like I said, you do not have to start at 0. Now you slowly open and close the stopcock. It's very easy to control so that you can get to the number that you wanted. Occasionally you will have a drop suspended from the tip of the burette. This drop is accounted for in the volume up here. So if it is just hanging there, you need to collect it on the glass or beaker that you're collecting the liquid in. So you need to actually touch the side of your beaker against the tip so that you can actually collect that drop in the beaker and so it is accounted for. All right, so we're at our starting point. We need to record our starting point. So our initial volume, 0.00 milliliters. We take another clean and dry 50 milliliter beaker. We're going to pre-weigh it, just like we did with the last one. We're going to record our mass. We're going to remove the beaker, bring it back over here. Now, carefully reading the instructions, it says to initially dispense about 10 milliliters. This does not mean you need exactly 10.00 milliliters. It just means that we need to have about 10, and we need to know exactly where we started and where we stopped. So my beaker is underneath my burette, and I'm going to dispense about 10 milliliters. I know exactly where I started. And we're about 10 milliliters. Now please refer to Dr. Conrad's video with reading the appropriate meniscus regarding these. So I've got 10.10 milliliters. I'm going to remass my beaker that now contains the water. Once it stabilizes, I will record that mass. Bring my beaker back over. I will add another 10 milliliters. Now the initial volume of the burette for the second time is going to be the final from the last time. So previously I had 10.10 milliliters as the final. That's going to be my initial for the next set. And then I read this one. Remass my beaker. All right, and then we just repeat this one more time. Mass, and I got my initial and final volume. Got another initial for the next 10 milliliters, excuse me. Alright, and then I'm going to remass my beaker and read my final volume. Alright, so we can drain our burette. Since we are done with that, we have recorded all of our data for part 2. For part number 3, this will be the determination of the formula of a hydrated salt. So we will be hydrating our salt using a Bunsen burner. We also need a ring stand, iron ring, plate triangle, tongs, the striker to start the Bunsen burner, and our sample, as well as a crucible. So first we can take the mass of our crucible. So we have a zeroed out balance. We'll take the crucible, place it on there, allow the balance to settle, and then record the mass. Next, we can remove our crucible. We need to add about 2 grams to our crucible. This is a very small amount. So as an example, you can see this is about 2 1/4. So I recorded the mass exactly, but it is not exactly 2 grams. It doesn't have to be exactly 2 grams. So we'll take our clay triangle, place it on top of our iron ring. Next, since this is cold, I can still touch it. Take the crucible with your sample inside of it, place it on the clay triangle. And then lighting the Bunsen burner is a little bit of a trick. This one is already good to go, so I will turn on the gas. Light the Bunsen burner, and then move the Bunsen burner under the sample. This will slowly dehydrate it by applying heat to the sample, and then you can just kind of gently move the Bunsen burner around so that you're not applying too much heat. Otherwise, the salt will start popping and you will lose mass by the sample actually coming out of the crucible. It takes about 10 to 15 minutes for this to actually dehydrate the salt completely. I will not put y'all through that. However, so it will take a few times for the salt to actually, or a few heating cycles for the salt to actually fully dehydrate. So with the hot crucible sitting above the Bunsen burner, I turn the Bunsen burner off using the gas in the back. Now I can take the crucible with the tongue, driving it by the sides, place it and allow it to cool off. A hot crucible does not weigh the same as a cold crucible, so you need to wait for it to completely cool off before you take the mass of the crucible again. So after about 10 minutes, you will remove the crucible, allow it to cool off, take the mass of it, heat it again for about 5 minutes, allow it to cool off again, and then take the mass of it again. Once these masses are within a few percent, you will know that you have removed all of the water from the salt, and the salt itself will look different as well. Once you have finished recording the mass of the actually dehydrated salt, then you'll be able to determine the formula for the salt.